Alright, this is section 3.3, page 5. We're going to do this problem. Looks like a pretty complicated problem. There are a couple ways to approach it. What I'm going to show you first is to actually FOIL out the numerator and denominator and then use the quotient rule. If I use the quotient rule right now without FOILing that out, then I would, in order to get the derivative of the numerator, or the denominator for that matter, I'd have to use the product rule. So the product rule embedded within the quotient rule. It's doable, but I think it might be more straightforward just to revise the function first, or to rewrite the function, and to go with that. So what we're going to do is we're going to FOIL first, and then apply the quotient rule. Okay, so if I FOIL first, let's just write this out. If I FOIL the numerator, I get, what do I get? 2x squared plus 1x, or just x, outside plus 4x, last plus 2. Here's the numerator. Denominator, what do I get? X squared minus 3x plus 4x minus 12. And just to clean those up here, 2x squared plus 5x plus 2 all over x squared plus x minus 12. Okay, so that's what I want to get the derivative of. And I'm going to use the quotient rule. So, quotient rule. Here we go. Y prime equals the bottom function, x squared plus x minus 12, times the derivative of the top function. So the derivative of that is just 4x plus 5. Minus is always used in the quotient rule. Start with the top, 2x squared plus 5x plus 2, times the derivative of the bottom, which is just going to be 2x plus 1. All over the bottom squared. X squared plus x minus 12, quantity squared. Okay, so that's the first step. Now I need to clean up the numerator. I'm going to actually distribute my 4x first. So I need to multiply these two. So I'm going to distribute the 4x to all these terms. So 4x, that's going to be 4x cubed plus 4x squared minus 48x. If I'm going to distribute the 5 now, I get plus 5x squared plus 5x minus 60. Then I'm going to do the same thing over here. Trinomial times a binomial. I'm going to distribute the 2x. But before I do that, this is a minus, so I want to be careful that I don't lose that minus sign, make a sign error. So I'm just going to put it out in front of all of this work. So here we go, 2x, that's going to give me 4x cubed plus 10x squared plus 4x. Now to distribute the 1. Plus 2x squared plus 5x plus 2. All over the denominator. I don't want to multiply anything out in the denominator. Leave it just like it is. Okay, next step. I need to clean up the numerator. So I can rewrite all this, and I have to distribute this negative sign. I'm actually going to take the time to write out that whole next row with all these negative signs. You could squeeze them in here if you want. I'm trying to be careful and not make a mistake. So this first part, I'm just going to copy as is. And then now distribute the negative. Minus 4x cubed minus 10x squared minus 4x minus, that's supposed to be a 2x squared minus 5x minus 2. All over same denominator. Squared. Okay, now combine like terms. How about x cubes? So I got a 4x cubed and a minus 4x cubed. Alright, those cancel. That's all there is of those. Now my squared terms. I have a 4x squared, 5x squared, negative 10x squared, negative 2x squared, So this is 4 and 5, 9 minus 1 minus 3x squared. Okay, how about just my x's? Minus 48x plus 5x minus 4x minus 5x. Let's see what I have all together. Minus 48 plus 5, that's minus 43, minus 47, minus 52x. And the only thing I should have left is whole numbers here. So I got minus 60, minus 2, minus 62, all over the same denominator. X squared plus x minus 12 quantity squared. And I'm pretty sure that wouldn't factor out. I'm not really going to worry about it. That's my answer. So that actually wasn't so bad. The alternate method that I mentioned, so alternate, would be to use the quotient rule from the get-go, but it would require product rule also. Okay, so I actually did that one already. I'm going to show you the results of that. And actually it looks pretty messy compared to what we just did. Here it is. This is when the quotient rule is done with the product rule embedded. So if you notice, the big quotient rule, but in order to do the derivative of the top or bottom in these brackets, there's the whole product rule required. Then I had to clean up in various stages, get the same answer. I wrote the denominator a little differently, but it's equivalent. I'm thinking I like the first way better. But if you want to study that a little bit more, you can pause the video and take a look at that. Let's go back to the one that we had. Oh, definitely looks better. Alright, let's continue on with problem 6. I'm going to save some space on problem 6. Here I'm going to actually find y prime, y double prime, and y triple prime. I want to do all of these. So we have y equals the square root of x. But we didn't really talk about how to do these problems with a square root. So I want you to think about, what would the power of this variable be? It would be y equals x to the 1/2 power. If it was a cube root, it would be 1/3 power. So now let's get the derivative of x to the 1/2 power. The power rule doesn't care if there's fractions in the power or not. You just treat it all the same way. So to get y prime here, I bring the fraction, or the power, whatever it is, down in front, 1/2. Variable stays the same. New power is 1/2 minus 1. Remember, we're always subtracting 1 from the power in the power rule. So y prime is 1/2 x to the negative 1/2 power. You could actually leave the answer like this, or we could rewrite it, because we know a negative power actually puts that in the denominator. The only thing here that is in the numerator is this 1. The 2's in the denominator. The x is in the denominator with the power of 1/2. And we could further rewrite it to be y prime equals 1 over 2 square root x. So these last 3 forms are actually all equivalent. It really wouldn't matter which way you wrote those. Now, if it's a multiple choice part of a test, you might have to manipulate to find an answer that matches, but that's what we have. Let's look at y double prime. Second derivative. Now, I need to consider which one of these versions would be the best to start with. And the radical form doesn't really help me much. Having a fraction with a function in the denominator, I certainly don't want to use the quotient rule here. So this one right here is already set up for ease of use. So I'm going to refer to that first one in order to do the second derivative. So here we go. The power comes down in front, negative 1/2. This 1/2 comes along for the ride, that's still in front. My variable is x. My new power, minus 1/2 minus 1. Remember, you subtract 1 from the power. So, what do I have here? The coefficient out in front is negative 1/4. There's my variable x, and my new power is negative 3/2. If I wanted to rewrite that, let's see, the numerator would just be maybe -1. The negative can actually go out in the front of the whole thing, but I'm okay with putting it right up top. 4 is in the denominator. X to the 3/2 power is in the denominator. And if I change this to a radical, I would get, since the 2 is the bottom part of the fraction, it is a square root. And on the inside of the square root is x cubed. Alright. Next one, I want y triple prime. What's the best place to start? And by the way, I forgot to mention, these three are all equivalent. So it doesn't really matter which way you express them. However, to do the third derivative, I want to be looking at that one right there. That's the one that's going to help me. It's in the right form to get started. So here I go. The power. -3/2 comes down in front. The fraction that's already there, or the coefficient that's already there, is -1/4. Variable is the same. New power is -3/2 minus 1. So y triple prime, what do I have in front now? This is going to be a positive 3/8. Variable x. 3/2 minus 2/2 is -5/2. So that's one answer that's sufficient. The numerator would have a 3 in it. 8 would be in the denominator. This is a square root. Oh, actually, I'm going to write it this way first. X to the 5/2 power. Now we'll change it to a square root. 3 in the numerator, 8 here. It is a square root of x to the 5th power.